in lesson 6.1, we'll be exploring exponential growth and decay, and it's going to be super exciting. One way we can represent growth of bacteria is to set up a table. So say you start out with 100 bacteria, whatever they may be, at times 0, and then after each hour they double. So after 1 hour you end up with 200, and after 2 hours you end up with 400, and so on and so forth. Now we could do this all day, but if we want to say after n hours, so any amount of hours, 100 hours, 200 hours, 1,000 hours, we could actually use a formula to figure this out. Now the expression that we would use would be 100 times, because 100 is our initial population, and then times 2, that 2 means that it's doubling, and we raise it to the nth power, which is how many times we're going to double it. So here's our basic formula to figure out what the population would be after either doubling, tripling, whatever it may be, after a certain amount of time. So we're going to go ahead and use this one in a couple application problems. Now the P represents our population, the initial population, what we start with. M is our multiplier, so whether it doubles, triples, quadruples, whatever it might be. Usually we'll be dealing with doubling and tripling in this class. And then time, the amount of time that we're going to go. So let's try a couple examples. So the first one here, we have 62 bacteria that double every hour. Find the number of bacteria after 3 hours, and we have our nice equation up here. So our initial population is 62, and we're doubling it, so times 2, and it's after 3 hours. So really we're going to double every hour, we're going to double 3 times. Now that's important, we're doubling 3 times, because sometimes we might be doubling every half hour or doubling every 10 minutes. It just depends on the problem. So if we plug this into our calculator, we end up with 496 bacteria. Wow, that's exciting. Now, I know what you're thinking. Well, what about if it lasts 5 hours? Oh, well, look no further. We're going to figure that out right now. We'll have 62 times 2, because we're doubling, and we'll raise it to the 5th power now. And when we do that, we get 1,984 bacteria. Holy cow, that is so cool. Isn't that right, Miss Folling?
So right.
So let's try a couple practice problems here. Feel free to try them on your own. Pause the video and then press play when you're ready to see that explanation. So for this first one, we have 76 bacteria that triple every hour. Ooh, they triple this time. That's cool. Find the number of bacteria after 5 hours. So we'll set it up as 76 times 3, because we're tripling it, raised to the 5th. Now I want to bring up a good point that Miss Folling brought up here, because this is a common mistake that students will make. They might do 76 times 3 and then raise that number to the 5th. You'll get something crazy big, right? Crazy big, like that new field house we got going in. So really what you're going to have to do is it's 3 to the 5th first, remember, because exponents come before multiplication. I mean, we wouldn't know about our dear Aunt Sally for no reason. Remember, PEMDAS, please excuse my dear Aunt Sally. So exponents come before multiplication. Boom! We'll get 18,468. The next one, we have 200 bacteria to start with. This one doubles every 30 minutes, so we're still doubling. And after 2 hours, well, how many times does it double if it doubles every 30 minutes after 2 hours? If you said 4, well, that's a score. We end up with 3,200. Woo! Awesome. Last one, 192 bacteria, and they double every hour. Still double, so times 2. And after 1.5 hours, we'll raise that to the 1.5. And that equals 543 bacteria. About 543. It's 543.058. So we'll just leave it at 543 for the number of bacteria. All right. You guys are rock stars at this.